Hello and welcome to day 2 of the UFAW virtual conference. I'm going to wait for another couple of minutes before I do the full introduction, but I've just turned on and sharing my screen with you so you can see that you are properly registered for the meeting. We're still waiting for more to join. I can see the numbers are increasing hugely as I'm talking to you. As you can see from this screen, the recordings of the sessions for yesterday, session 1 and session 2, are now available to watch on demand, and I've put the web address on this slide. So if you want to watch those at any point, if you had difficulties yesterday in watching some of the videos, that's the place to go to see them. So we're just waiting for some more people to come in before we start the session. I'll give it another 30 seconds or so and then I'll do the introduction. So hello everybody, welcome and thank you for joining us. My name is Stephen Wickens and this is the second day of the meeting Recent Advances in Animal Welfare Science 7, our first virtual conference. This is the third of 5 sessions over 2 days. These sessions are being recorded, but to watch each live you need to have registered for each using the link we previously shared with you. Recordings of sessions 1 and sessions 2 are now available online to watch, and you can see from this slide that's up at the moment and the email that's previously sent to you, that's the link that you need to use to watch these. The conference features talks from a great range of speakers, and you can ask them questions for those of you who didn't watch yesterday's using the chat or question tab in the meeting drop-down menu. Also to remind you, we have an extensive range of innovative posters that you can look at too. There's over 60 of these. The link that I posted yesterday didn't work when it was uploaded as a handout. So to access the conference posters, please use the Dropbox link in the email too that was sent to you to see these. And if you wish to ask any of the poster presenters any questions, you'll need to contact them directly using the email shown in the abstract booklet. We also have some other handouts you can access via the drop-down menu. This includes money off for books of the UFAW Wiley-Blackwell series and a certificate of attendance for the conference. You can download these, but you need to do so before the session ends. So as I've said, this is the first of such meetings we've run online. And for those of you who were around on day 1, you saw it was a bit of a learning curve for us, so apologies for some of the technical gremlins. But we hope, once again, you bear with us today if there are any technical issues. There were a few people who had audio issues yesterday. So the audio issues, I'm afraid, I can't help you with. It's something you need to address yourself, either by looking at the audio settings on your computer, or there is an audio panel on the Dropbox menu too. You might want to click and move things around on. Okay, so that's my introduction. We are actually going to have a few words at the beginning to formally welcome you from UFAW's chair, Dr. Alec Simmons. Alec?
Good morning, everybody. My name is Alec Simmons. As Stephen said, I'm the chair of UFAW, and I wanted to welcome you to this virtual conference. As you know, it's already the second day, so some of this might be superfluous to a number of you. But I wanted to say a few words just to put a bit of background into this. As you know, UFAW is in the forefront of science in the support of animal welfare and the service of animal welfare. And we do that in a number of ways, through publications, through research grants, through studentships, but also through conferences. And we've been holding a number of these. As you see, this is the 7th one we've held now, but it's the first virtual one. Conventionally, we would normally expect to get anything between 80 and 100 people to come along. But as you can imagine, a conventional conference has been paid to by COVID-19. So I was very pleased that the executive, in the shape of Hugh, Chief Executive, and Stephen Wiggins, came up with the idea of doing this virtually. And we have had over 1,000 people register. Not all of those have managed to get here each time, but the reach of this so far has exceeded all of our expectations. We've already got 275 people signed up today, in fact logged on right now, and yesterday we had over 480. And what's important to us is that there's been more than 47 countries involved here. So what it's doing is extending our reach, and I think that's absolutely marvelous. So I'm very pleased to see how many people of you have got involved, and I think it's a new departure for us all. And I never really thought that the pandemic would really offer a great deal of should we say benefits, but this I think is a hidden benefit, in as much that the reach and the extent of the organisation has increased as a result of it. So that's excellent news. And I wanted to thank Stephen Wiggins and Hugh Gollage and other UFAW members staff members for the efforts that have been put into this, and it's already proving to be a success. Excuse me. I've no doubt the rest of it will be. So I hope you are able to listen and get yourself involved into this as much as you possibly can. And I wish you every success, and excuse me, that you enjoy it as much as I'm sure I'm going to. So thank you very much.
Thank you, Alec. So we now come to the beginning of the formal part of the session, and the first speaker for session 3 is Elske de Haas from Utrecht University, and she's going to be talking about ranging behaviour in organic layers and broilers and the relationship with welfare.
Welcome to my talk. This study is part of the Free Birds project, which is a core organic funded project. Core Organic is a European funding for organic production systems. The Free Birds program of project is a collaboration between the Netherlands, Belgium, Sweden, Italy, Poland, Denmark and Turkey, with the aim optimization of the use of the free range as a key to improve organic chicken production and welfare. In this study, we looked specifically at ranging behavior in organic slow-growing broilers and their relationship with welfare. Having an outdoor range is a prerequisite for organic poultry. Having such an extensive outdoor range promotes natural behavior, as it gives ample opportunities for foraging, for exploring, for I don't know what, running, dust bathing, sunbathing, and therefore it also provides choice. Either the bird can go inside or outside, go far, go near, and do whatever they want, and therefore it promotes welfare. In a recent study by Taylor et al., it was found that conventional broilers, 95% of them who were tracked individually, they go out. So that's nice information. However, what we know is that many chickens range close to the house, as you can see on the top picture. And also they do not distribute themselves evenly, which means that if they go out, they might be in a very high stocking density, which then results in not having those nice welfare benefits which I explained before. Instead, they may deplete the soil and destroy the vegetation, and it all becomes a very barren condition, as you can see in this top picture. This also causes that the water may drain down, and you get pools of water, which can cause diseases. You can have parasite infections, and also they can have wet feet for exiting to the range, which can not be good for their welfare. But what we also know is that some chickens do go far, as you can see in the bottom picture with the white circled chicken in the corner of the far end corner of the range. And in this study we want to know if we can facilitate this sort of far ranging, and how does that link to the individual's welfare. And we have a situation at ILVO in Belgium which is quite unique. we have a field of 90 meters long and 22.5 meters wide, where we place mobile chicken houses. In the top picture you see the situation as it is recently, with our laying hen conditions, which have 2 houses, but in the broiler experiment there were 4 houses situated. There are different zones. In the bottom picture you can see a sort of grass field area with small shrubs of hazelnuts growing, and behind the mobile houses there's more forest-like area with willow trees growing. So animals have the opportunity to either go into the forest-like area, spend some time on the grass, go inside, outside, whatever they want. Furthermore, this site has the unique opportunity to individually track the chickens. And this is our experimental setup. We had 4 houses, and each house housed 100 Saso organic meat type chickens. Tracking was done via an ultra-wideband system, where an active sending tag, which contains also a battery, sends out a signal to a receiver. We set the sampling rate on every 6 minutes. And when at least 3 anchors or receivers detect the location of that tag by the line of sight, by triangulation the exact location can be established. We choose to have 10% of each group tagged, and they wore the backpacks, which contain the tag and the battery, for at least 10 days. Welfare scoring was done at 12 weeks of age, looking at the extent of having hock burns, foot pad dermatitis, gait score and cleanliness, where a higher score indicates a worse condition. The figure which is shown here is the location of all individuals over the whole study period. So you can see 4 different houses in the colors green, red, blue or grey, and you can roughly also see the different fields, the different zones. So if we look at a greenhouse, we see a red zone, which is the grass-like area, and a blue zone, which is the forest-like area. So the birds do come in both zones and also in the far ends, but maybe not as extensively. Also, what is noticed is that the corners of the field are cut off, and that is done real life by placing a fence, because if a bird is under the anchor, it cannot be detected properly, and the accuracy of detection is then very low. So therefore the field was cut in the corners. This figure shows the proportion of time an individual bird spent in different distances from the house. These are all our tracked chickens. So none have a 0 time spent outside, so it means that all chickens were going outside. Looking at the different colors, we have red represents 0 to 1 meter distance from the barn, so that means still very near to the barn. More orange beige color is 1 to 2 meters from the barn. Now we have yellow-green, which is 2 to 5 meters, so spending more time in that area means the birds are getting a little bit more brave. Then we have the blue zone, blue colors, which is 5 to 10 meters, and the pink purple colors, which is 10 to 20 meters. That's the very brave ones, maybe even fearless ones, I would say. So we see that the majority of birds spend the most time near the barn, but some individuals also spend more time in further distances. With this location data, you can calculate the different ranging parameters. So here I correlated the different parameters. So in the top left picture, you see on the y-axis the distance walked, and on the x-axis the walking speed. And here we see that there's a strong correlation between, say, activity and distance the birds walk. Then on the top right figure you see the y-axis, the time spent outside in minutes per day, and the number of transitions on the x-axis, which means the transition from one zone to another zone, so either from the house to the grass to the willows and back, and in different kinds of transitions. And what we see is that the time spent outside was positively correlated with the number of transitions, so meaning a lot of time outside is likely also going to different places. the time spent outside on the bottom picture in the y-axis, and on the x-axis the average of walking distance of an animal per day, do not have a very strong correlation. So some birds may spend a lot of time outside and go very far, but some birds may spend a lot of time outside but they stay very near to the house. If we look at these variables for ranging in the different zones, so we have close to the house, grassland or forest-like area, as I explained earlier. Here we analyzed 3 groups because one group had very many missing recordings, so we could not assess the walking speed or distance walk accurately. Therefore, the analysis is done with 3 groups. For all the 3 groups, it was shown that the walking speed was higher in the forest-like area as compared to the grassland or the house. So they are more active in this forest-like area. Also for the distance walked, we saw for all the groups that they had a higher distance walked in the forest-like area as compared to the grassland or near the house. So it means that the birds are likely more active and they go further where there's a sort of a natural vegetation. Here we categorize the birds on activity level based on the transition to different zones. So we have very active birds who go to different zones very often. We have low active birds which stay more in one zone, and the moderate ones which go more or less to different zones. When we then look at the time they spend in each location per day on the y-axis, we see that the active birds spend less time near the barn in zone 1, but spend more time in zone 2, the grassland area, and in more time in zone 3, which is the forest-like area, as you can see in the picture, as compared to those other categorized birds. When we look at the correlation between welfare and ranging, we had only 6 animals which had moderate indication of welfare with a high score for heartburns and footpad dermatitis. So only 6 out of our 40 trapped chickens had indications of welfare issues, which is a good result. But if we want to correlate that with ranging, it's a little bit low on the variation which we had. So we had no extremes, for example. Nevertheless, we found no negative correlation between heartburns, which is the second top, second circles in the line, which are the heartburns, which had red is a negative correlation between distance walk and speed walk, but very low. We also found a low positive correlation, which is the third line of circles, with distance from the barn. So if they had footpad dermatitis, more severe score, they spent more time close to the barn. When we look at ranging and welfare, we saw only 6 out of 40 tracked chickens with issues. We also have to say that we had a small flock number as compared to commercial conditions and a relatively small enclosed range, but that was also our setup. So this could also indicate that this kind of setup is positive for their welfare. Furthermore, slow-growing broilers had fewer welfare problems than conventional fast-growing broilers. Other tracking studies with conventional fast-growing broilers have shown links between welfare and ranging, which is very interesting that they found distant rangers have a better gait and lower stress compared to close rangers, and if they had more visits to the range, they also have a better gait, plumage, and lower ascites index. So this indicates that ranging and welfare are positively correlated. Optimization of the range, as our aim from the Freebirds project, indicates that birds prefer dense natural vegetations over artificial kinds of ranging situations like shelters, because Stadig et al. Found that they prefer this and also go further in this forest-like area, which is done in the same experimental site. High percentage of birds ranging is also positively correlated with the amount of tree cover. So having more trees, it causes more birds actually to go outside, or maybe even go further, as Stadig suggests. And here you see a picture also of all the birds under the trees providing shadow, but it also provides some safety. So So it reduces the risk for predation because they can hide for birds of prey. It also reduces the risk of avian influenza or other transmittable diseases from wild birds, which maybe cannot land on the range as they would if there were no tree cover. So our suggestion is that the optimization of the range with natural vegetation would be ideally to stimulate ranging behavior, also for slow ground broilers. And with that, I want to thank my supervisors, Bas Rodenburg from the University of Utrecht and Frank Tuyttens from the Institute for Agricultural and Fishery Research in Belgium. And I had help with the statistics from colleagues out from Cicero in Australia, Hamideh Keshavarsi and Dana Campbell, Bart Ampe from the Research Institute in Belgium, and all our free birds collaborators and animal caretakers and colleagues from ILVO and Utrecht are thanked for their inspiration and listening to my pondering and discussing of ideas. And with that, I want to thank you all for listening, and if you have any questions, either now or via email, I'm willing to answer that. Thank you very much.
Well, thank you very much, Elske. So we're now moving on to the questions. So if you could turn your camera and your microphone on, thank you. Very interesting talk. We've had some come through. The first one, Benjamin Lecourt, straight out of the block. Thanks for the talk. I wondered, what was the early experiences of these birds, indoor, outdoor versus brooded and non-brooded?
Yes, the early life conditions were that they remained indoors for 21 days before they were getting access to the outdoor area. When you say brooded or not brooded, they were all like not brooded by a mother hen, or so to say. They did have a condition with using a dark brooder, and we had two different groups. So one group was brooded with a artificial dark brooder, and another group was the control conditions. And we're going to look more in detail if those conditions affected the ranging behavior.
Okay, thank you. Question from Heather Maggs. Were any of the chickens in your study able to roost when outside or only range?
Sorry, can you repeat that?
Were any of the chickens in your study able to roost when outside or only range?
Well, the willow trees, as you saw in the picture, they were quite high at that point, but they are not so well for roosting. They're sort of too weak to really sit on. So, and generally they all went inside during the dusk period. So I think they all roosted inside. We did maybe have there could be some issues with closing of the door, which started when the light intensity outside was lower. So it was automatically closing. So it could possibly be if one will be too late, it will be outside, but generally they're all roosted inside.
The two questions asking a similar thing was how practical this would be in a commercial poultry setting. How would you see it being taken up?
Well, if this is kind of an agroforestry condition, so not having only production for meat or egg production, but also having for example, some nut production from the hazelnut or from the willow trees. You can also have biomass. So it's a combined situation. And if you would implement it in a commercial condition, you could improve maybe the ranging and have sort of a positive effect on the plant conditions if they don't destroy the vegetation. But that would be the ideal situation, to have like a more natural area for the birds and also have a good production of other sources, such as maybe small fruits could also be used, like cherry trees you see sometimes, or small like raspberries or that kind of berry trees do also quite well.
Thank you. Another question from Helen Gray. Do the chickens range more because their welfare is better, or does more ranging promote better welfare? How can the causality be disentangled?
Yeah, that's a tricky thing. And there was a recent study done by Taylor looking at fast growing broilers. And they looked over time also at different welfare parameters to see if you can, that was also done on an individual level, to either see if the welfare is reducing, and that also affects the ranging behavior, or if it's the other way around. And for that, you need, I think, measurements before and after, or maybe even during your experimental period, to really understand what happens. In general, what was found is that in that study, birds which had a better gait score, which is sort of an indication of a good mobility and also low leg problems, so no hock burns or something like that, they would go further in the range. So they were more the distance rangers. So it could indicate that they have also a better welfare, but from it, either is it from the ranging, or is it because they already have better welfare, and that's why their range far is still a little bit difficult to establish.
Okay. And a final question: how did you choose the 10 days to track their ranging behaviour? And would you expect their ranging behaviour to be stable over time?
No. Generally, you see that it actually increases over time. Well, we were using a backpack, which is, maybe I can share my screen and show you a picture if there's still time for this.
Yeah, we can, if we're quick with that, here we go. So changing screen.
Show my screen. So this is a study from Lisanne Stadig, which shows a picture of this backpack. So on a 70-day-old chicken, and as you can see, it's quite big. So in this case, with using an ultra wideband tag, which requires also a battery, it requires also a casing around it, and also a big backpack. So for small chickens, for chicks, it's way too big. So you can only start tracking when they're at least not affected by wearing this backpack because of the weight or the other dimensions of that backpack. But if you have other kinds of tags, such as RFID tags, which are very small, but they are passive, so they need birds need to pass a certain antenna to be registered. There you can actually track them already from when they were very young. So we chose a period which was known not to affect their behavior and welfare, and also their meat characteristics from earlier studies, and to also compare it with those studies. In the end, we did an analysis to have at least good representation over time, and so that was the last 10 days of their fattening period.
Thank you, Elske, for your very interesting presentation. Thank you. So we'll now move on to the second presentation in session 3, which is Laura Kubasiewicz from the Donkey Sanctuary, and she's talking about the Welfare Aggregation and Guidance WAG tool, a new method to summarise global welfare assessment data for equids.
My name's Laura Kubasiewicz and I work at the Donkey Sanctuary. I'll be talking to you today about the Welfare Aggregation and Guidance tool, which is a new method we've developed to summarise global equid welfare data. We find equids in a huge variety of situations all over the world, from working equids in the brick kilns and coal mines, those used as pack animals in the mountains, to equids in production, where they're used for their meat, milk and skins, as well as equids in sanctuaries. So whether it's driven by consumer concern for production animals, by owner compassion, or by a need for to demonstrate welfare standards by equid welfare charities or livestock regulators, for example, we need a standardised way to measure and report on welfare. And given the huge variety of situations equids are found in, it's really important that we have tools to cover all of those scenarios. To start to address this, the Donkey Sanctuary recently developed a new welfare assessment tool, the Equid Assessment, Research and Scoping, or EARS tool. And this welfare assessment draws on existing methods and adds some new indicators of welfare to make sure that all species of equids are covered and make sure that it applies to all different contexts in which equids are found. It includes assessments for foals and for free roaming equids, which was a bit of a gap in existing welfare assessment tools. So once we've completed those welfare assessments, we have a huge amount of data to work with. And this can create a little bit of a problem for decision makers to try and kind of digest and understand all of these separate indicators for each individual equid. So we need to aggregate that down into a representative score for welfare. And that will allow decision makers to look at broad scale trends that might be global trends in welfare to try and figure out where to allocate arguably limited resources. There are a number of existing welfare aggregation methods, such as the Welfare Quality Assessment and the Animal Needs Index. And these are really widely used methods, but they mostly cover production animals. So we wanted to create a new aggregation process that would cover equids in all different scenarios around the world. And in looking into those existing methods, we identified a number of challenges that developers had come across that we want to try and tackle when we develop our new aggregation methods. So, for example, do we need a single welfare score? Are the different components of welfare comparable enough to be combined, or could we have a suite of scores that represents the scope of welfare? Can good welfare in one area compensate for poor welfare elsewhere? Is it appropriate to use environment-based measures as well as direct animal measurements to assess welfare? Is the process transparent and understandable so we can delve into the drivers behind poor welfare? And do important attributes within that process have enough influence? I'll go through the process of development now for the Welfare Aggregation and Guidance tool and talk through how we address some of the challenges from previous methods along the way. So the first question was whether or not we need a single welfare score. And we decided to aggregate our data down into 5 categories and stop there. So we have behaviour, health, nutrition, working conditions and living environment. And that gives us succinct enough data that it's easy enough to interpret and look at those broad scale trends. So it's useful operationally, but it overcomes some of the pitfalls of having a single welfare score and combining data that might not be comparable. It also helps us to overcome that issue of compensation, at least between the different components of welfare. And it helps us to pinpoint where we need animal and environment-based measures. So for health and behaviour, we focus solely on animal-based measures. For nutrition, working conditions and living environment, we incorporated some environment-based measures where those were more appropriate for the categories. Now that we've got our categories, we took all of the questions from the EARS assessment and asked 2 experts to rank all of them based on which had the biggest impact on welfare if the worst case scenario was realised. So in the example here on the right, these are the questions for behaviour and the rankings from experts. So we also asked experts to rank the answers to these questions based on a traffic light system, but I'll talk a bit more about that later on. We then select the 4 top ranked questions for each welfare category. So the 4 selected for behaviour are displayed in the table there. And by keeping this uniform across all categories within the process, we ensure that all attributes are firstly the most important in terms of indicating poor welfare, and that they have the same influence over the overall score. We then build a decision tree with those 4 questions. So there's 1 decision tree for each welfare category, and that keeps the process nice and transparent. There's only 1 stage of aggregation, and it's the same for each of the categories. So we can start to look back over the process to find out where those drivers of poor welfare are. So here's an example of a decision tree, and this is again the one for behaviour. So each of our measures of behaviour forms a level on the tree, and the answers, as I mentioned before, have been ranked from best welfare on that traffic light system being green, and that would get 25 points, to worst welfare, which is red and would get 0 points, and then amber, which is worth 12.5 points, is our answers that fall in between. So the equid on the right here, if we assessed him based on this decision tree, would get 62.5 overall, and that's on a scale from 0 to 100. So all of the decision trees are standardised in terms of score. So once we've built our decision tree and we have a score for each individual equid, we need to assign those individuals a grade. And this is fairly straightforward. So equids with a score of 90 to 100 would be graded an A, 80 to 89 would be a B, and so on. Finally, to allow us to start to look at those broad scale trends in welfare, we need to combine those individual grades down into a population grade. So we want to make sure that the equids in greatest need are represented in this process. So to do that, we've used a really useful component of the welfare quality assessment, the 15% rule, whereby you add up the percentage of animals with each grade from the bottom up, and that gives you a cumulative percentage of animals with that grade or a lower one. So the overall grade of the population is the first grade you get to where that cumulative percentage is greater than 15%. So that's the process, and to demonstrate one of the uses, I'll draw on the EARS data we have so far. We're lucky enough to have a really big data set of over 7,000 assessments collected so far all over the world. And a good chunk of those were collected from countries in Europe and Asia. So the first stage is to look at where globally, and very crudely, to focus our attention. So looking at the health grade, here we find that countries in Europe get an overall grade of C for health, and the plots here show the distribution of individual grades within that that cohort. And for Asia, we got an overall grade of D. So we can see already that we need to focus on Asia. Then looking more closely at the individual grades for countries within Asia, we can see that the lowest health grade was for equids in Pakistan. So we now can start to focus in on that country and find out what were the driving factors that were reducing the health grade there. The 4 questions we used in the health category are signs of illness, signs of skin system alteration, occurrence and severity of lameness, and signs of respiratory disease. So the graph here shows the proportion of animals in the cohort that were scored as having a kind of poor welfare for each of those measures. So those are the red bars. Middling welfare for the amber bars, and good welfare for the green. And we can already see 2 questions that stand out as having particularly high proportion of animals with poor and middling welfare there. So for skin system alterations, we found that a high proportion of animals had open wounds and alopecia. And looking at the data a bit more closely, it seems that all of the equids in the cohort worked as either draft or pack animals. So the next stage would be to start to move towards doing some more assessments for harness fitting and for handling to reflect the type of work that these animals are doing and the most likely causes of those wounds, so that we can make sure we understand what the underlying causes are before we try to improve conditions. For signs of respiratory disease, we found almost half of the animals in the cohort had signs of eye and nasal discharge. And because most of the equids in the cohort worked in brick kilns and coal mines, it's likely that that has an environmental cause, although we would need to go and do more surveys to confirm if that's the case. And if so, we'd then advise some social research in the brick kilns themselves to try and figure out how we can best support people in changing the conditions for the equids and for the people as well. We understand from some other research that there tends to be either social or economic factors that are most likely to have a big impact on making a sustainable change there. So that would be a good starting point. Moving on to our next case study, the Nepalese brick kilns. We work closely with a partner organisation, Animal Nepal, who have kindly collected over 2,000 assessments for us in the brick kilns in Nepal, and that's across 41 brick kilns over 2 regions. So we can start to get a really detailed picture of welfare conditions there and pinpoint areas of greatest need. And as well as the different districts and kilns, we wanted to see if there are any differences in welfare between demographic groups for the equids as well. So a very brief look at results for this case study. We found nutrition to be fairly uniform across the demographic groups and across regions, but the main driver for poor nutrition was access to clean water, and that was during working and resting times. So to try and address that, we'd try and develop a relationship with kiln managers there so that facilities can be improved. For the health category, health was found to be poorer for donkeys than for mules and horses, and that was due to a prevalence of scars, alopecia and open wounds, and those seem to be caused, after looking at the more detailed assessments that we have, by poorly fitting harnesses and equipment. So we would advise training on making and fitting those. For behaviour, we found behaviour grades to be worse for older donkeys in one particular region of Nepal, so we could focus our efforts there. And poor behaviour scores tended to be driven by a prevalence of limb tethering. So we would work with communities in this case to try and find alternatives and sustainable alternatives that work for the communities there. If there aren't any, we could then look to at least improve the materials that tethers are made from. For working conditions, the poorest working conditions were found in kilns that use horses and mules as opposed to donkeys. And this was due to a lack of shade and a lack of rest breaks as well as long working hours. So there were quite a lot of factors here that could be improved. And for this case particularly, it would be really important to collaborate with human development organisations. So we know from some other research that a lot of the drivers for poor welfare are really interlinked with social and economic factors for people that own equids. So taking a one welfare approach here would be ideal to try and improve conditions for the equids and for the people. And finally, the living environment, so this is housing of the equids, was found to be poorest for horses and for kilns that use carts as opposed to pack animals. So horses in these kilns tended to be kept indoors and not have access to outdoor space when they were resting. And again, following the same theme, we try and work with the community and work with kiln managers to improve the facilities that are available within these kilns. So that just leaves me to say thank you for listening and to thank all of the staff and volunteers at Animal Nepal and the Donkey Sanctuary for data collection, and also to thank all of the equid owners and handlers that have allowed us to do these assessments on their animals.
Thank you very much, Laura, for your talk. Now's the time to ask Laura questions. Great, I can see you popped up. Excellent. So we've had a few that have already come through. The first of these is from Megan Jones. She said, thank you for the really interesting presentation. Sorry if I missed it, but how did you collect the questions for the WAG and from whom?
So all of the questions in the WAG process are taken from the EARS protocol. So that's a welfare assessment, a really comprehensive welfare assessment that the Donkey Sanctuary developed just prior to the WAG being developed. So all of the questions came from there.
Great. And within this too, sorry, it's perhaps a little similar. Matt Leach says, can you tell me how many experts were consulted to identify which indices to include in the scale? What level of consensus was required for inclusion in the scale too?
Okay, so we had a minimum of 2 experts per category. I think in reality, we actually had 3 or 4 for some of them. And those experts were all experts in the particular category that we asked them to look at. So we had different people looking at each of the categories. So for example, for the health and nutrition categories, we had vets and a nutrition expert. For the working conditions, we had a harness fitting expert that's worked with a lot of working animals. And for the behaviour category, we had 2 behaviourists. So we asked them to score each of the questions separately. We then compared their answers. If there was a consensus already, that was fine, we could go forward. If not, we asked them to discuss with each other kind of the reasons behind any differences in any of the questions that they'd selected, and then go away and score them again. We'd come back together and see if we had a consensus. If not, we went through the same process a couple more times. If after all of that we still didn't have a consensus, we had a kind of fallback that we would take average scores between all of the experts and use the questions that came up that way. In practice, we didn't need to do that because we had a consensus after. I think we only needed a single discussion round for the behaviour category, and we had a consensus already. So yeah, that was the process.
Excellent. Question from Stephanie Lerzel. Thank you for the interesting presentation. If I understood correctly, the question about the presence of other equids was not selected to be included in the protocol. Does this mean that an equid kept singly would not show up to have impaired welfare? Would you not consider that to be problematic, or does it just not occur?
I would. It's an interesting question actually, because we did that was in the behaviour protocol, and that was one of the questions there was a little bit of a discussion about. It fell, I think, 5th on the list. And yes, I certainly would consider that to be a problem. I think it's kind of weighing up best case scenario between having a simple, transparent process where we only have these 4 questions. So we're certainly not going to capture everything within that, between kind of the pitfalls of making a more complicated process with all of the drivers in there. And we went for the more simple process in this case, and so that question wouldn't be included. But what I would say is that we strongly encourage people when they're using this process to just kind of use it as a springboard. So we're using it as a start point to try and identify areas of greatest need, but then we would draw on all of the EARS information to try and find out a bit more about the populations that we're working with. So that information, although it's not in the WAG process, it's not lost. We would still be using it.
Excellent, thank you. So Jenny Cooper asks, how keen are the handlers to improve things for their animals?
In our experience, very keen. A lot of the time it's more a case of not having the resources to do so. I think we've just published some research actually looking at the kind of socioeconomic drivers of good or poor welfare, and we have a couple more in the pipeline, which suggests that it's people are really keen to improve conditions, but they either feel that they don't have control over the situation and they don't have any means to do so, or it's a kind of financial thing where they have a choice between feeding their family or improving conditions, and they're in a kind of state of perpetual debt, particularly for working equids, and we've worked a lot in the brick kilns there. So yeah, I think it's more about kind of ability to having enough resources to do that, rather than kind of understanding that it's necessary as such.
Thank you. One last question, and it needs to be sort of, you've got a sort of couple of minutes for this. From David Pritchard, the welfare problems you found are similar to those found by other methods over decades. And he asks, why is WAG better than previous methods?
I think it's the scope of it. It means that we can look at equids in any scenario. So whether that's working equids, those in production, we can use it on our farms in the sanctuary. We could use it for domestic equids as well. So I think that it's the adaptability of it, but also the fact that we can drill back down into the process to find out what the drivers are. So I think a lot of the existing processes are fantastic, but this one keeps things a lot more simple. So we can look back at the questions that we have and find out what's kind of the driving force behind the scores that we're seeing. And then we've got the wealth of information behind that as well that we can start to then pinpoint. So I think the transparency of it is probably the biggest benefit.
Okay, thank you, Laura. Thank you very much. So we'll now move on to the next session, the next talk, which is Chanakarn from the University of Glasgow. And she's going to be talking about surface temperature reveals magnitude of restraint stressor, sex differences, and lateralisation in rats.
Hello everyone, I'm Chanakarn and I'm so glad to be here at the UFAW Animal Welfare Conference. The topic of my talk today is surface temperature reveals magnitude of restraint stress, sex difference, and lateralisation in rats. In my talk, I will introduce you first to stress-induced hypothermia paradigm, which is relevant to infrared thermography that I used in my study. Then I will outline the aims of my study and the methods to achieve them. And next, I will show you the main results stated also in the title of my talk, and we will discuss them a bit, and I will finish with a summary for you. So let's get started. Since stress is of great welfare importance, one of the physiological animal welfare markers is termed stress-induced hypothermia, which is the rise of the core body temperature upon encountering stressors. It is a general phenomenon across species and stimuli, and it is also reported to be magnitude dependent and correlates to stress hormone levels. For example, this previous study in mice shows the rise of the core temperature increased with the increasing intensity of stressors. The first stressor is just tapping the home cage with a finger. The second stressor is picking the mouse by its tail. The third stressor is picking the mouse by its tail and puts it into a novel cage. So you can see the pattern of the core temperature increased with the magnitude of stimuli. However, measuring the core temperature is invasive and can confound the results, requiring insertion of probe or surgical implantation of a locker. Fortunately, the increase of the core temperature is coupled with a decrease in the surface temperature due to peripheral vasoconstriction of the skin, and now the skin temperature can be measured reliably and continuously using non-invasive infrared thermography, or IRT. IRT has been applied in captive and wild settings to study thermobiology, veterinary diagnosis, population survey, and stress-induced hypothermia in both humans and animals. That was because IRT has several strengths. It is non-invasive and non-contact, which won't disturb animals' ongoing behavior, and it gives continuous and real-time measurements. Additionally, it has the potential to be fully automated in the future. As this last year study, partially funded by UFAW, published Thermolab animal software to measure the mean body surface temperature of mice. And there is an ongoing research, also funded by UFAW at the University of Bristol, using IRT to assess animal emotion based on thermal lateralisation, with a right hemisphere dominance for processing negative emotions and a left hemisphere dominance for processing positive emotions. The mechanism of thermal lateralisation is not clear, but lateralized difference in tympanic membrane temperature has been reported to be related to the effects of lateralized cerebral blood flow. Another strength that also makes IRT a potential animal welfare marker is that it is magnitude dependent, as we found in chicken from the work of Herben. But nothing is known yet about quantifying stress using IRT in mammals. So, the aims of our study are, firstly, to check if IRT can detect stress magnitude in mammals starting with laboratory rats by using 3 restraint stressors with different intensity level, to examine dynamic changes, optimal sampling interval, and anatomical locations. Secondly, there is evidence of sex effects in behavioral and hormonal responses to stress. So we used both sexes of rats to explore if there is any sex difference in thermal response to stressors. And thirdly, we used both left and right sides of the body parts to explore thermal lateralization as well. For methods, we used 36 Vista rats, half male, half female, approximately 5 weeks old on arriving date, housed in a group of 3 of the same sex. They all went through acclimatization, habituation, and testing periods. In the testing period, the rats were feed for individual baseline surface temperature for 30 seconds in the female arena, which they were previously habituated to. Then, the rats were randomly put into 3 groups. Each was exposed to one of the 3 restraint stressors with different intensity or magnitude for 1 minute. The first group was put in a small novel cage, the second group was held with encircling handling, and the third group was put in a plastic restraint cone. The order of the stressors magnitude, according to previous studies, are mild to severe respectively. Then we filmed each rat for 30 minutes post-stressor for behavioral and thermal responses. We tested that 60 seconds was the optimum sampling interval. However, since surface temperature was known to respond quickly initially, so we sampled every 10 seconds for the first 4 minutes and every 60 seconds for the rest of the videos. We excluded the extremities such as nose and paws, which were rarely seen in most of the images. So we have extracted surface temperature of 5 regions of interest, which were left and right eyes, left and right ears, and tail, as shown in this figure. We also found that compared to the average and the minimum temperature, the maximum temperature was the most accurate and reliable measurement. We analyzed the maximum temperature of each region of interest using general linear mixed model in R, and we corrected for autocorrelation and controlled for all the variables potentially affecting the temperature reading. So, these are what we found. First, the response over time of tail, eye, and ear temperatures reveals stress magnitude. The tail temperature cooled down as you can see from the thermal images that the tail color gradually changed post-stressor. And this graph is showing the fitted lines and confidence intervals of the tail temperature difference from baseline over 30 minutes post-stressor filming of each restraint group. The tail temperature cooled down within 5 minutes after being exposed to the 3 stressors, and the tail temperature was then coming back towards baseline, and some rats even had an overshoot. It seems that the difference of the magnitude was clearer during the recovery. Unlike the tail, the eye and the ear temperature increased from baseline after exposing to stressors. The response over time of the eyes and the ears also revealed stress magnitude. However, the ears in the restraint cone warmed up during stress exposure, even it was just 1 minute, and the effect lasted a bit, as you can see from the blue line of this ear graph, started at a very high point from baseline. So far, I didn't explain much about the order of the magnitude of the restraint stressors, and that was because it is also depending on the sex of the rats, which, for the tail, while the male rats responded to stressors in the expected order, it was the opposite response in female rats, and female rats never recovered. When we analyzed each sex separately, we found that the magnitude effect only remained in the male rats. This is just to show you that we did look in detail for the tail temperature response of each individual rat to find out where the difference is in the thermal response curve. Although every specific curve property reveals significant stressor and sex interaction. When we analyzed each sex separately, the amplitude of the drop lost stressor magnitude effect in both sexes, while all the curve components, for example, the slope from the lowest drop to the highest peak, reveal still the magnitude of restraint stressors in both sexes. So one cannot tell how stressed a rat is by simply looking at the extent of the cooling of the tail, but by measuring its timing and the dynamics of the recovery. Sex difference was found also in eye and ear analysis, with the same impression that in female rats, the temperatures didn't seem to move back towards baseline. And when we analyzed each sex separately, we found that the magnitude effect remained for both sexes for the ears, but only in female rats for the eyes. Another main result to highlight is that we found thermal lateralisation in both eye and ear temperature, where the right side revealed greater response than the left. With that being said, when we tested for site and sex interaction, we found that the eye and the ear showed laterality in thermal response depending on sex. Only male rats showed strong right lateralisation significantly in both eye and ear responses to stressors, while female rats showed no significant eye lateralisation and an opposite direction of ear lateralisation, but much weaker. So, there are some discussion points. First, IRT reveals magnitude of restraint stress and thermal lateralisation in rats, but these effects are sex-dependent. The tail of male rats responded to stressors in the expected order, but not the female rats. This may be because the work we based on had only tested in male rats. The different response of the female rats can be due to the different perception of each stressor, different thermoregulation, or different neurological structures contributing to emotion in female rats. My next experiments are to further validate the stressors with behavioral and hormonal assessments. Next point, the increased eye and ear temperature might reflect core temperature, while the decrease of the tail temperature might reflect vasoconstriction capacity of SIH response. And there is strong evidence that the right brain hemisphere predominantly involved in fear and anxiety responses. Although lateralized physiological reactions such as body temperature is not clear, these asymmetries may be also reflected at the level of the eye and ear surface temperature. But we will investigate valence further by doing another experiment using 3 levels of positive stimuli and see what happens. We are also looking forward to new techniques that would allow IRT filming in the home cage to make it more practical to use. To summarize, firstly, IRT has the potential to quantify stress with a number of benefits. Secondly, we found a very strong male and female difference, emphasizing the importance of using both sexes in animal welfare research. Thirdly, thermal lateralisation was detected, and if this is confirmed with a positive stimuli study, then IRT might be able to review valence. The impact of this study is a refinement of laboratory animal use in stress research and to improve the welfare assessment of laboratory rats, which can be a transferable knowledge to other mammals and other fields of study. Well, that's it from me. I would like to thank these amazing people and organizations, as well as the rats. Thank you very much for listening, and please let me know if you have any questions.
Thank you, Chanakarn, for that very interesting presentation. You can ask questions using the chat box, and some have come through. Hello, hi.
Hi.
So we've got first question is from Megan Jones. She asks, was the temperature of the room kept consistent throughout experiments? Could external temperature have an effect on the surface temperature of the rats? And could manual handling with hands increase temperature?
Yeah, so when I was first looking which animals to first explore in mammals, so we chose laboratory rats first, mainly also because the laboratory condition was more controlled and stable than in the field. And also we have recorded the ambient temperature and humidity, which also found to be affecting the reading of the temperature of the surface temperature by the infrared camera. And we also took that into the analysis and we include that in the model, but we didn't find any significant effects from these variables. And with the handling, using the hand, I didn't say in my presentation, but we used also the insulating gloves for this experiment specifically to prevent the heat transfer. But because of the insulating glove that I used is quite big, and when we were holding the rat in the encircling handling or in the restraint cone, I think also the glove can still affect by alter the microclimate there, and that's why we saw the ear and the eye temperature have a really high temperature at first. But however, that the restraint duration was just 1 minute, so that's why the effect lasted not very long.
Thank you. A number of questions about sex. First one is, did baseline surface temperature differ between sexes?
Well, yeah, so actually the previous studies also found that the female have higher baseline temperature, but in my study, when I was analyzing the temperature, I was using the individual baseline and then deducted from the temperature rating. So what we're analyzing is the difference temperature from baseline.
Thank you. So interesting from Anna Juffinger. She said your results seem to suggest that males showed a greater stress response based on temperature change than females. Could the fact that you found significant lateralisation in males but not females be due to the lower response of stress from females than stresses?
Yeah, so the theory of the lateralisation in the thermal response, it was expected that the right should be more responsive than the left side of the body, but that was more significant and more stronger in males. I think this is also due to, it's not yet clear in rats, but in humans, there are difference also in the sexes between the lateralisation, because there is lateralisation in the neural structure of the associating with emotion, where in men is more dominant in the right side, and in the women is more dominant in the left side. There was no that I found the work that done on this in the rats, but I think that could also affect the results reading, the thermatorization that I found.
Thank you. Nuno Franco has a question. He said, hello, very happy to see how your work's progressed.
Yes,
He's pushing, saying he's substantially upgraded his software and it might be of use to you. But his question is, and he's saying he might have missed it, are you using a specific point in the tail or evaluating mean tail temperature? And I'm asking this, he says, because even when we used maximum tail temperature, we found high variability between observers.
Yes. Oh, yeah. I also was thinking about that. Whether I use the maximum temperature, the average, or the minimum temperature. And the method I was drawing the temperature of the tail is that I draw a line along the tail for the whole tail. So starting from the base of the tail, where it's starting to have a laterality and symmetrical, and then going to the tip of the tail. But when I was analyzing between the repeatability between the maximum, the average, and the minimum, it was more variable in the average and the minimum temperatures. And also with the condition that I was filming the rat, there were no sources of heat. So there were no radiation or the heat sources that could lead to overestimation, but there were some sources that could lead to underestimation, such as motion blur and also the waste of the animal that could, because I was putting also the bedding into the filming arena, so sometimes there were urine and feces, and that sometimes the beddings also cover the tail and might change the temperature. So I was thinking that there were more confounders in the average and the minimum temperature. That's why I used the maximum temperature. So when you saw in the picture, the maximum were more at the base of the tail, but that was picked by the software which point. So I didn't see for every image where it is, but it's more likely to be the base of the tail. But I draw the whole line along the tail. So.
Probably time for a couple of questions. Do you think there would be any difference in baseline temperature between young and older rats using the same methods?
Oh, yes. Well, to be honest, I do think that there are will be difference between ages and between strengths as well. But I didn't include that in this study yet, and just the sexes now that I found differences. So yeah, I do think that there will be another variable that introduced into thermal reading of the surface temperature.
Thank you. And the final question, is there a chance that sex hormones, rather than neurological differences, may be involved in the different responses of male and female rats?
Sex hormones. Oh yes, yeah. Yeah, I got this a lot. A very good question. So lately we found more and more evidence that the estrus cycle was not relevant to the difference in the stress response in female rats. But however, that wasn't the main reason that I didn't do the vaginal smear in this study. But because this study was testing the acute stress from restraint, and I think the accurate way to assess the estrus cycle or estrus stage, it was to do the serial several repeated handling and then do the vaginal smear repeatedly before and after the time that that I did the filming. So I didn't test for the estrus cycle, but that could or couldn't be the reason for the variation in the females. So.
Thank you. Thank you very much. Very interesting talk. So we'll now move on to the next presentation in session 3. Thank you. Thank you. Irene, could we ask you to turn your camera and mic on, please? Hello. Hi. And Hugh, if you could do the same. So Irene's about to talk about the importance of micro-expressions in animal social interactions, and she's at the Polish Academy of Sciences. But as importantly, as Hugh will explain, she's also showing herself at the moment for a different reason.
Thanks, Steve. So yes, for those of you who weren't here yesterday, I had the very great pleasure of announcing that Irene is UFAW's Young Animal Welfare Scientist of the Year 2020, and I was hoping to present the award virtually to her when internet gremlins got in the way. So I just wanted to just say congratulations to Irene again. She's done some really wonderful work in welfare science, but also in disseminating that knowledge and advocating for change, which is exactly the kind of thing UFAW likes to acknowledge in its awards. So it's once again my very great pleasure to present Irene virtually with our Young Animal Welfare Scientist of the Year award.
Thank you. Thank you to UFAW, and also many thank you to the people who nominated me and supported me in my career throughout. Mainly the colleagues from Edinburgh, and also Fekna Tuni, Simon Turner and Jean Laurent. But most of all, mainly also the students, not only for data collection, but students give such a good feedback. You know, you go with them to the farm and they start crying, or they get angry at you saying, is this what you call high welfare standards? And that makes you really think again about that conventional is just not good enough. It's not acceptable to even students of agriculture who get into the farm for the first time. And I really see like every moment that we are wasting our time. Research takes so much time, the whole process up to the publication. And every second that we waste, all these millions of animals are suffering worldwide. And I really hope that we all together as animal welfare researchers can make some change in the future for that. The sooner the better. Thanks again for the award.
Fantastic, congratulations. We can really see your passion, which is why you won this award. So let's hear about the science now. Thanks very much,
okay.
Irene.
Thank you very much, Irene. I'll play the video.
Hello, thank you for joining this presentation online. I was informed that around 1,000 people have registered for the conference. So I wondered, what if 1,000 people, or even 500, will be listening? Then what is important enough to say? Based on that, I would like to briefly highlight the importance of human health, well-being, and human activity in general on the lives of animals and animal welfare. In the last few months, we have of course seen very extreme examples of that, where the understaffing and closure of slaughterhouses has resulted in the destruction and culling of millions of animals, often in very horrible ways, not only for the animals, but also for the people involved who had to carry out these kind of tasks. And of course, we may also have to consider the welfare of many animals that are still alive, but in conditions that is not suitable for them because of overstocking, as they cannot bring animals to the slaughterhouse. Similar as that a few people can have a negative impact on the welfare of many animals, we also may consider our own role as animal welfare researchers and how we can contribute in a positive way to animal welfare and in awareness of societal awareness of animal welfare in general. So to improve animal welfare, we also need to improve human well-being and awareness. And to start, it's always good to look first at yourself, at your own well-being. And I'm sure that many of you have been quite severely challenged in the last few months with all the changes that have taken place. To help gain insight in how the pandemic has influenced animal behavior and welfare research, as well as researchers, we now have a survey online which asks you a few questions about, for example, how your work has changed and how you have been able to cope with it. And I know there's so many surveys at the moment online, but this one is really specific for our field of research and how we take action based on changes that have been happening. I'll put a link also in the last slide. But actually, I was meant to speak about micro-expressions in animals, and specifically social interactions. The term micro-expression has been coined in 1966, where it was used for facial expressions in psychotherapy in humans. Paul Ekman continued with this and then developed the facial action coding system, which also has been used for non-human animals like primates and horses. The term micro-expressions hasn't really been used in research. Facial expressions, the field of facial expressions is really growing, luckily, but micro-behaviors haven't been really applied, and the overall concept of micro-expression hasn't really been adopted in animal science. Last year during my ISAE talk, I suggested that the micro-expressions can be used in animals to look at behaviors, movements, or signals that typically last only a few seconds or less. And in human literature, they used a threshold of 4 seconds for this, although often it is much shorter. Micro-expressions are extra important in non-human animals because their communication is mostly non-verbal. And this is of course very obvious, we all know this, but at the same time we have used it way too often to say like, oh, we cannot ask them what they're feeling, or we cannot ask them about their emotions because they cannot speak. And the fact that they cannot verbalize it doesn't mean that they cannot communicate it. In fact, animals have very elaborate communication, but it just needs much finer, has finer details in the bodily expression. Here you see a few examples of micro-expressions that have been used quite often now, like ear postures, eye white, which has mainly been used in cattle, and muscle tension, which has been used in the Grima scale, for example, for pain. The purpose of micro-expression, at least in my opinion, is to look beyond the behavior at the expression of emotion within the behavior itself. So you can look at an animal as standing or walking, but it will do so in a certain way, like it is a more qualitative scale. And this has also been, of course, studied with a qualitative behavior assessment. But the micro-expression really gives a method to quantify these kind of things. They quantify the expression of the behavior. And the aim of this talk really is to provide an example of how micro-expressions can be included in etograms and how this can contribute to the study of social interactions. For this, I studied a group of free-ranging pigs of the Alentejano breed, a native breed in Portugal. I looked at 32 growing pigs out of a group of 70 animals that were walking on 40 hectares of land, and 17 sows on pasture. I looked at each individual for 30 minutes continuously, and only during the active hours. In the etogram, I distinguished 25 micro-behaviors of social, neutral, and positive interactions, and I combined it with a common etogram of 11, let's say, macro behaviors like walking, standing, eating, and so on. You see here a range of the micro behaviors, and I mainly would like to highlight that I make a distinction between proximity and contact. Contact is really the physical direct contact, whereas proximity is anything less than 30 centimeters, which I used here for pigs. In other species, you may of course want to apply a different threshold for that. I'll now show a very brief video showing no snout proximity during locomotion. It goes really fast. So you see the two animals are approaching, but not making contact, and they continue walking, making it very short, and often missed. It's like watching a GIF video that plays over and over. When we look at the results of the macro behaviors in pigs, which is like the common etogram, we see that most percentage of the time is spent on locomotion, which is here walking, and eating, which is here grazing. The rest is spent on exploring, which is in this case rooting in this scenario. Very small amount is spent on agonistic behavior, and standing happens sometimes, and out of sight you can imagine how that happens if they suddenly get startled and run away across the fields. In the south is a very similar picture, and I mainly show this to show how different it is from a behavioral pattern in indoor housed pigs, where they are lying often, and where this distinction between active hours of the day and resting hours is much less clear than in a natural setting. When we look at the micro behaviors for pigs, we see that nose-head proximity occurs most often, more than 25 times per 30 minutes. So if you sum up all micro behaviors, you get several behaviors per minute, which gives a nice data to work with. It's not like, for example, play behavior that occurs very infrequently and therefore is very hard to analyze. I think that's also one of the reasons that we lump together a lot of behaviors because of the difficulties with analyzing them, but that's here luckily not the case. When we look at nose-face contact, we see that it happens much less than nose-head proximity. However, when we see nose-body contact and nose-body proximity, they are very similar. This suggests that pigs differentiate between whether they approach the head of the animal or whether they approach the rest of the body of the animal, making them more reluctant to directly contact the face. In south, we see a very similar pattern, mostly nose-snout proximity, and much less so nose-nose contact. Whereas again, nose-body contact and nose-body proximity are very similar. This differentiation between proximity and contact based on the body part is to some extent already a bit known, but not yet so well documented. When we look at agonistic behavior in pigs, we also have a nosing phase just before a fight starts, as you can see in the one photo on the left. And this is recording as nosing behavior, but they actually don't make contact, and fighting may happen soon after, which results in a correlation between a lot of nosing and a lot of fighting, making it look as if it's negative. However, on the other hand, nosing behavior with nose-nose contact is also seen a lot in affiliative contexts. So you see also nosing behavior in a lot of positive situations. If you lump them all together as nosing behavior, you miss this distinction and you see nosing both as negative and positive, whereas actually you can separate them out and say nosing proximity may happen more in agonistic contact, whereas nose contact itself may have a more affiliative kind of meaning. Measuring this kind of micro-expression requires an experienced and fast observer because it does go very fast and the etogram is very long. However, there's a huge scope for using technology, and in facial expressions, this has luckily already been picked up, for example, by infrared thermography, where the technology is really advanced enough to pick up things that we cannot really easily see with the human eye. Clearly, there's much going on which is not recorded. We know that it's going on, but we don't know really how to record it, or if we have recorded it, how to analyze it, certainly if it happens infrequently. It does offer the opportunity to study low arousal states, as it looks at so much more fine details. Also, this gives the opportunity to reduce the intensity of studies, because often in tests, animals are stressed and they give a much more extreme response than they would do in a natural context when they are, for example, interacting with their conspecifics. And when we are able to look more at the subtle kind of signals, we can interpret the animal better in a more natural situation. In conclusion, microexpressions provide more detailed information than we currently have, and this gives the potential to assess the valence of the behavior as well. It can also really lead to the refinement of tests, and we can develop the ability to adapt our technology to the subtle kind of communication of animals, rather than to provoke the animal sufficiently to give a profound response that can be easily measured. We should find the ways that most reflect the animal rather than what is most easy for us. Also, I'd like to invite you again for the survey that is online. It's really about how this pandemic has influenced specifically animal behavior and welfare research, and what kind of impact it may have on the research that has been done, as well as the researchers. I also like to point towards the YouTube channel Animal Welfare Science. I upload here some short informative videos for the general public, and it's a nice platform to get responses, and if you want your video uploaded there, then please contact me. Last but not least, I would like to thank the farm for allowing me to do their study with their pigs. Also UFAW for giving this opportunity to have this talk here, and COST for funding part of the research. Thank you.
Thank you very much, Irene. Very interesting talk. Lots of questions were coming in. I've shared some of them with you, so I hope you're ready to answer them. First one I'm going to direct towards you is from Moira Harris. And she says, when recording your behaviour observations, if the pig was doing more than one behaviour at once, which is quite common, how did you decide which to record?
So I did record the behaviors at the same time. I recorded a micro behavior that they were doing, so something very fine and very small, but at the same time they're doing a macro behavior that we usually record, such as standing or walking. So I recorded the way you usually record the interaction between two animals, that you say this one is biting number 2, and instead of having a receiver, I put let's say the micro behavior as the modifier in the program, so that you can record them at the same time.
Thank you. Long question from Lucy Asher, which she apologises for. Microexpression in people are believed not to have a communicative function, but rather reveal inner states we are trying to conceal. Do you think the same may be true in animals? Would it depend on the duration? Because a micro behaviour to us, which we generally wouldn't notice in others, might be a different duration to a micro behaviour in another animal.
Yeah, good question. In humans, these micro behaviors, they say anything less than 4 seconds, but in reality, in humans, the techniques are so fine that it's often a fraction of a second, and then it's mainly facial expressions. Humans do notice also these micro expressions. For example, how you notice that someone is nervous for a talk is because of these tiny things that you wouldn't even hardly recall, but the complete picture gives an expression of the emotion more than the behavior. And the same way we can use it in animals. So it's more about the valence of the behavior than the behavior itself. But the difference indeed for different species may differ. Some animals are just faster than others also.
Thank you. Question from Paul Rose, which, if you know him, is about birds, actually. He said, could there be an application to non-mammalian species? Would posture changes or feather positions, for example, be relevant descriptors of this type of approach for assessing bird welfare?
Yes, it's for any species. For example, even with facial expressions, they can do this on other species than mammals. And I don't see a limitation for specifically mammals only.
You showed that behaviours differed in forms, e.g. contact versus nosing proximity. But do you think they differ in function or meaning of the animal?
Yes, this is very hard to, because we can record what they're doing, but the interpretation, well, is difficult sometimes. Also with his nose contact and nose head proximity, we only can guess a bit the meaning of it because of the different contexts that we have measured already previously, for example, aggression and affiliative behavior. But there are so many micro behaviors still for which we have no clue of why they occur in a certain way, or if it's actually relevant for the animal or not. For example, with certain display behavior or even tail movements or so, we don't know if it's even communicative or not, because in some species it is and in others it isn't. So you cannot really generalize here in this. There's still a lot to discover.
Question from Caroline Walsh says, when you differentiate between contact and proximity, does the contact have to last a certain period of time, e.g. 4 seconds? We have found that during very brief interactions in dogs, it's very difficult to reliably make the distinction between close proximity and contact.
Yes, indeed. It is difficult to make this distinction between proximity and contact, but it is, in my opinion, really essential. And you need to have the good situation that you can see it properly, or measure it in another kind of way with technology. But this difference between very close and touching, I think for the animal it matters, or at least for pigs, and I think in dogs it will also matter. But it's a way of refining our methodologies to include these kind of things.
Another question. Can dog sitting position be regarded as a micro-expression in piglets suffering from scrotal hernia?
I didn't get the question exactly.
Can dog sitting position be regarded as micro-expression in piglets suffering from scrotal hernia?
I don't think it's a micro-expression because it's longer than 4 seconds as one part of the definition.
Thank you. Dan O'Neill asks, are these learned, therefore different between groups? In other words, are these micro-expressions cultural?
Are these micro-expressions?
Yeah. Do they differ between groups? Are they a cultural thing that the animals learn, or are they?
Maybe. This was just the first group where I tested it. And I will use this for different groups and then can answer it in a few years' time, maybe.
Excellent. Great. Well, I think that's those are the questions we've had in. Thank you very much, Irene, for a fantastic presentation, and congratulations once again for your young animal welfare scientist award. Well done. So we now move to the final speaker of session 3, which is Adrian Smith from the Norris Norwegian University of Life Sciences. And he's going to be giving a short talk which introduces his workshop that makes up session 4 that follows this session. And he's going to talk about improving animal welfare and scientific quality, guidelines for planning animal welfare science. So I'm going to share my screen with Adrian. Adrian, I'll turn your microphone on for you. Okay, it's not turned on. Yeah, okay, it's on now, and I will change presenter, so you'll need to accept it.
Yeah. Yes.
Great, we can see your screen, Adrian. I don't know if you want to have your camera on too.
There we are.
Hello. Yeah, we can see you, and we can hear you, and we can see your screen.
Is my camera in the way? Would you like me to?
No, it's perfectly placed.
So if I go into the presentation form, you should have that on the screen now?
Yep, we've got your, yes, it's full screen now.
Yeah, good. Thank you very much, Stephen. And thank you for this opportunity to talk about guidelines for planning animal studies. I really appreciate it. And I'd really like to commend Stephen and UFAW for all their work in making this conference online. I don't think we have any idea how much work it's involved getting all the technical aspects up and running. I've chosen to hold my presentation live, although there is a recording as a backup if necessary, because first of all, I was a bit worried about any issues with the audio, and secondly, to try and make this as intimate and get as much dialogue as possible. As Stephen said, I'm just going to talk for 10 minutes quickly now before the break. All my slides, the ones now and after the break, are available at the address on the middle of the screen, noricopa.no/UFAW, so you don't need to write anything down, which also gives me an excuse to talk quickly, because I feel rather like Bill Bryson, who wrote that book, A Short History of Nearly Everything, which is what we're going to try and cover in these 2 short sessions. And do feel free to email me afterwards if you have any other questions or comments we don't get time for. My address is also on this first screen. So a quick overview of what I consider the need for planning guidelines now, and then after the break, we'll look at some of the available tools and give you a chance to comment on those. Just a couple of words about Noricopa. We call ourselves a consensus platform for the 3 Rs. And although we're stuck away in the northeast of Europe, we aim to be a source of global 3R resources and spend a lot of time collecting them and putting them out on the web. And our motto is to prepare for better science, whether that science be with or without animals or animal products. We're called Noricopa because we're one of the founding members of ECOPA, which is the European Consensus Platform for Alternatives. And ECOPA recognizes any one national organization that has all these 4 stakeholders in their governing body. That's the regulators, scientists, people working in industry, and animal welfare organizations. So we aim for consensus, advancing the 3 Rs, increasing understanding between all the stakeholders. I wonder if you noticed this sentence on UFAW's website, that science informs, motivates and facilitates advances in animal welfare by providing a strong evidence base and creating practical and effective solutions to these. Well, that's precisely what we're trying to do as well. So I'll be talking about the PREPARE guidelines, which was a collaboration between Noricopa and British experts. We, as I said, have a comprehensive website providing global resources for providing the evidence base that you need to make these important changes, including now recently a refinement wiki, which I'll come back to. The site is fairly large, as you can see now, and attracting quite a lot of visitors, and that number is increasing by about 30% a year at the moment, so we're very happy about that. We also collaborate with other 3R centres, and in Europe there's a network of 3R centres, and we have an interactive map on our website where you can find more information about each of these centres. And if you represent a new centre that we haven't heard about, then please let us know and we'll add you to that map. We heard about One Welfare just now, and we're also very concerned about attention to human welfare. So we host the website of the International Culture of Care Network. I'll come back to that briefly after the break as well. And because of the need for new contingency plans and methods for coping with the COVID-19 pandemic, a lot of resources are now being developed to help people with that, and we've made a website collecting links to those resources, and also actually resources for school children who need to do home learning. So just a personal view of why I feel we need to focus more on planning guidelines. I'm getting a bit long in the tooth now, and I've been working at animal facilities and supervising research and talking to scientists on courses in lab animal science for quite a few years now. And although the animal welfare and rights organizations have been talking about a reproducibility crisis for many years, the scientists are now increasingly talking about this themselves. Not just defending animal research and pointing out the poor internal and external validity of animal studies. And I feel very strongly, having worked so long in the animal house with the animals behind these closed doors, that one of the greatest challenges to this reproducibility lies within the animals themselves and the way in which we use them. And I suspect that many scientists are unaware of the size of this challenge, or they assume that the animal facility is dealing with it. There are a lot of really nice papers on how we can improve reproducibility. This is just one of them by Marcus Munifer's group in Bristol. And this is the sort of thing we see in many of these papers. The threats to reproducible science are described, and they include often things like bias and the various causes of that, low statistical power, p-hacking, poor data quality control, and poor statistical analysis. What I feel I often miss in these papers is more focus on the animal-related issues, the ones that people like myself, lab animal vets and technicians, carers working behind the doors of the animal house see every day, and which we know can have just as much influence, if not more, on the validity of the data coming out of the experiments. So I always get a bit frustrated when I hear comments like, oh, we can solve the reproducibility crisis by courses in experimental design, when what they really mean is the more mathematical aspects like randomization and blinding and blocking and choice of experimental unit, etc. There's so much more to experimental design than just that. And another frustration I get is people say, well, we can solve this crisis by better reporting. This is a burnt cake. And however well you describe it, unless you're a brilliant psychologist, it's still a burnt cake in everybody's eyes. And the only way you can produce a better cake is by going back to the kitchen and changing the ingredients and or the baking conditions. And reporting guidelines, to be honest, are not new, and they haven't solved the reproducibility crisis. Of course, we need good guidelines, and we've had plenty of them for many years. So I can remember as soon as I started working in this branch in the 1980s, that people were pointing out the need for better reporting guidelines. And we do need them, but they are not the only solution to the crisis. In fact, my colleagues, Eddie Clutton from the University of Edinburgh, Elliot Lilley from the RSPCA, Christina Hansen from the Norwegian University of Applied Sciences in Oslo, and Trond Bratteli from Western University in Norway, wrote a paper in the BMJ journal a couple of years ago saying that we seem to be wasting time discussing the quality of the lock on the door of the stable from which the horse has already bolted. And that I thought was a good opportunity to bring in the UFAW logo, where you can see the horse going into the stable, and that's where we need to start if we're going to improve the quality of animal research. I live out in the country on a farm, and on occasion we have to take down big trees like this. And if I was going to describe to you how I did it, well, the easy parts are the mathematical aspects, if you like, the characteristics of the chainsaw, the angle of the cut in the tree, and the length of the logs I'm going to cut this tree up into. But there are a lot of other critical issues behind the scenes that rarely would get reported. For example, checking that the people involved were experienced, checking the tree itself for signs of rot, or decide which direction to fell it in. The additional equipment we would need with a tree this size, the routines for looking after the equipment, and not least clearing up and transporting the logs, getting these heavy logs out of the forest afterwards. and not least, in this case, the health and safety precautions, the clothing, attention to the onlookers, division of labour and costs. And I hope you see some possible analogies with animal research here. And these issues start long before the actual work itself. I found a paper recently by this Dutch cardiac surgeon, Luc Norris, which I rather liked. He said, measure twice, think 3 times, cut once. That I think is a rather good way of looking at how we should be doing our research. Abraham Lincoln is supposed to have said, give me 6 hours to chop down a tree and I'll spend the first 4 sharpening the axe. So what I want to talk about more after the break is this relationship between planning and reporting, and how we should do it, who we should collaborate with to make sure that we get everybody on board and that the result is safe, it's valid, and it's reproducible. I'm going to stop here, but I would like to ask you to spend 3.5 minutes of the next half-hour break to have a look at this little cartoon film, which we made to illustrate what I've been talking about, using the aviation industry and their enviable precision and reliability as an analogy. You'll find it at the, or links to it at the address at the top of this slide, noricopa.no/prepare/film. And as with so many people, we've put 4 links there. So you can either download it from Vimeo or Facebook or YouTube or LinkedIn. And we'll cross our fingers that these websites manage the pressure of so many accesses. If not, anyway, I'll be going through some more of these elements related specifically to animal research after the break. So that was all I was going to say now before the break. It's back to you, Stephen.
Thank you, Adrian. That was very interesting. So, and thanks to all the speakers who've spoken today. Adrian's workshop will be taking place at 13:20, so in half an hour's time. It's session 4, so please have your questions ready for this, and we'll try to be as interactive as possible for this session and for the session 5. Please remember that you need to register for these if you haven't already done so, and the registration links for those are in the email reminders you've been sent. And just to remind you, Adrian's session 4 starts at 13:20, and session 5 starts at 2 p.m. UK time. So thank you, Adrian. We'll finish the session now and look to many of you to see you in about half an hour's time. Thank you.